All right. So what is a database? What exactly a database has? How the data would be stored in the database? So yesterday in the demo session, I was talking about, so initially when the software started evolved, whenever the application development takes place, we have like front end and back end. So back end is actually the database which holds your data, right? So what is a database? Database is nothing but it is a container, it is a holder which stores your data in a two-dimensional structure format, right? So it holds two-dimensional structure format. So if you want, if you see that, let me show you. Yeah. So what is the two-dimensional format? That means rows and columns. So whenever you store any data, the data will be stored in a table in the two-dimensional format, rows and columns. Say suppose this is a session. Okay. And you are all students for this session. I want to store your student details. Okay. How do I store student ID? Because every student must have a unique ID to represent, right? So student ID, student name, student phone number, student session, student address, right? What is the skill set of student? What is the course that is applying for, right? So these are all the things I have in the student table. So it has rows and the columns, both it has. So it will be a two-dimensional format. So here it would say that so column 1, column 2, column 3, column 4, student ID, name, address, and all. Then A, B, C, and phone number is 1, 2, 3. So these are the rows. These are the columns, and these are the rows. So it's a kind of a two-dimensional format, right? So basically, the data gets stored in the database in the two-dimensional format. So whenever you are working on any application, whenever you are using any application, the backend data will be using the database to store the database, right? So this database is called transactional database. As I mentioned earlier, yesterday, it's called transactional database. It's also called operational database. Okay, it's also called OLTP, online transaction processing, right? So transactional database, operational database, online transaction processing. So three set of names which we can refer to when it comes to the actual database which gets stored, right? So what are the transactional data? Why it's called transactional database? Why it's called operational database? Suppose you are going to a bank and you are opening an account, then there is a transaction. You are depositing some amount in your bank, that is a transaction. You are swiping a credit card in one of the shop, then there is a transaction, right? And you are opening a locker in your bank, that is a transaction. You are going to hospital, right? So in the hospital, when you get when you consult a doctor and your details will be added, that is a transaction. You pay some money for your consultation, that is a transaction. And suppose unfortunately you are getting admitted to the hospital, then invoice will be generated, that is a transaction, right? All the transactions will be stored in the transactional database. So it's helping to operationalize the application. So that is the reason it's called operational database or transactional database or online transactional processing. Okay, transactions are being processed, right? So this is actual database, right? So whenever you're storing the data in the transactional database, right? So over the period of time, the data keeps on increase, right? Suppose today just I opened my bank. Today is the first day. Today I established some bank called PC Bank, and 2 customers came for today. But over the period of time, it will be hundreds, thousands, lakhs of customers, lakhs of transactions. Over the period of time, what happens? The transactions keeps on increasing, right? So at the end of the day, what a bank will do, what a management will do, suppose you have small shop, kirana shop, suppose, okay? So at the, or any provisional store, Okay. End of the day, what the owner will do? The owner calculates all the money, saying that okay, today 10,000 rupees collected. Okay, and around 10 Johnson Johnson products got sold, and 10 kgs of rice bags sold. Right. So these are all kind of analysis he will do at the end of the day, and based on that he will plan for next 1 month or next day. Right, isn't it? That's how the planning will be done for any business, right? uh, Same way the management also need to do a planning. So what they do at the end of the day, they will generate some report saying that okay, today suppose hospital. Okay, so how many patients came, what kind of test they did, okay, how many doctors got consulted, what is the amount that I got. End of the day, hospitals also profit based, how much profit they got. So these are all things they will note down. Based on that, they will plan for next years or next months based on that. Suppose so COVID patients are increasing, then add some more COVID wards, COVID beds, right? So these are all the things they will do at the end of the day. How would they do? They will write some queries against the transactional database. Okay, select star from patient tab, patient data, where the disease type something something, right? So these are all the queries they need to run against your transactional database to get the data, right? But when the data keeps on increasing, you are using the same database for the queries, for the reporting. At the same time, you are using the same database for your operational database. Okay, so transactions also getting stored in the same database. You are generating the reports also in the same database. What happens? The load on the database keeps increasing. Then what happens? There will be performance hit. So it takes so much of time when you perform transaction. It's kind of hard. It kind of stucks. And whenever you're retrieving the query for reporting, that also gets some time. So both the ways either neither transactions are getting benefited nor the reports are getting benefited, right? So to overcome that problem, people decided we should have a separate database to get the reports. Okay, to generate reports, we should have a separate database, right? So that's how the data warehouse concept came into picture, right? So the data warehouse is the place where we store the data from the operational database for the decision making process, right? So it can be every day I can store at the end of the day, or every 1 hour I will store, or every 1 month I will store. It all depends upon the scenario and the requirement. But basically, you are going to maintain a separate database to store the data. Right? Now, let us talk about some of the basic definitions of the data warehouse. Okay. So decision support database that is maintained separately from the organizational operation database support information processing by providing a solid platform for consolidated historical data for analysis. So it's also called decision support database. Okay, because you're taking the decisions out of the database. So it's a decision support database maintained separated from the operational database, which is the platform for consolidated and historical data. So it will have all the historical data, 1 month data, 2 months data, 10 years data, 20 years data, and also consolidated, that means aggregated data. Right? Say suppose today 10 transactions I'm performing, 10 customers came into my bank. Suppose you perform 10 transaction your account. Okay, at the end of the day, what I'm going to store in the database, okay, in the data warehouse, how many customers are added, how much deposits have been added, how many lockers got opened. I don't go into individual record. I will take the aggregated data, then I will store in the database. The database usually will have consolidated aggregated data. Right? Now, once I store the data in the data warehouse, I will keep generating the reports out of it. I don't need to worry about the operational database. So operational database will take care of its operation. The data warehouse will take care of its reporting purpose. Now, there is a distinguish between these two now. Right? There is a separatism between these two. Right? So a data warehouse is subject oriented, integrated, time variant and non-volatile collection of data in support of management's decision making process. So WH Inman So Inman, so is a kind of is the one who defined the actual data warehouse initially. He says that so data warehouse is subject oriented. So basically the data, whatever you store in the data warehouse is subject oriented. Means whatever the record you're storing, that is subject oriented. Subject means what? Suppose a supermarket example I'm taking. When you store the data in the data warehouse, you need to analyze based on the subject. So the subject can be a product, a subject can be a brand, a subject can be a city, a subject can be a country. So whatever the analysis that you're doing based on the subject. Okay, that is the reason it says that subject oriented data. Integrated means the data might be in different locations. The supermarket database, suppose the application might have different databases, all the transactions, but we integrate all the database into a single place. Time variant means each record will be associated with the time. Okay, for 2000 sorry June 23 2022, how much transactions happen? June 20 2005, how much transactions happen? Okay, so these are all kind of a time attached to time. And non-volatile means it doesn't change. So when you store the data into data warehouse, it's basically used only for the reading purpose. There won't be any changes, only appends. That means you keep on adding the data, but you don't change the existing data and you don't delete the existing data. You keep on adding. So non-volatile. So basically data warehouse will have the data which has 4 properties: subject oriented, integrated, time variant, and non-volatile. So all this data will be used for the decision making process, right? So that's about the data warehouse. Now data warehousing is nothing but the process of constructing using the data warehouse is nothing but data warehousing, right? So here if you see this diagram, so the data warehouse, the sources can be multiple sources, source 1, source 2, source 3. So we kind of integrate everything into a single place, okay, and store it in a warehouse. Okay, so the transactions will be performed on the different databases because an application can have a number of databases. Finally, you integrate and store the data into the data warehouse. From there, the query will be happened. The queries will be filed against the data warehouse, and a client, that means a user, will generate the reports out of it. Right? So this is at high level what exactly the data warehouse is. Right? Sources, integrate and store the data in the warehouse from where the reporting generation will happen. Right? So warehouse is nothing but is also one of the database. The name is different. We are just calling as data warehouse, but actually is also one of the database where we are storing the aggregated data. So the data warehouse is also called, data warehouse is one of the terminology which we use, right? And decision support database, decision support system, DSS, and also called OLAP, online analytical processing. Okay, it's called online transaction processing. This is called online analytical processing. Okay, because it's for analysis purposes we are using the data warehouse. That is the reason it's called online analytical processing. Are you clear with the simple definition? Does anybody has any doubts before jumping
Hey,
into
BC,
deep dive?
I read this site. So I have, hello. Yeah.
Yeah,
So
please tell.
one thing is that, so in transactional database, so we are getting the data and we are storing it. So where this transactional database is getting stored? Because OL the then aggregated data we are storing in data warehouse, but
Right.
where the transactional data is getting stored?
So these are transactional data, the database. Source 1, source 2, these are all the transactional database. Suppose you have one application, say
Okay.
some
And
supermarket, hospital. So the backend will be transactional database. There can be a SQL server, or can be Oracle, or any database, or can be anything. Sometimes it can be a file system as well, Excel as well, CSV as well. That's where your transactions getting stored.
okay, so okay,
Yeah, go ahead.
so when we are copying this, when we are copying this data in storing in data warehouse, so it's gonna create another record of the same data.
Yeah, that's what I
It's
said.
like a duplicacy.
No. That's what I said. Integrated data. Okay, integrated and aggregated data. Aggregated in the sense, if you remember, I was talking about, suppose your 10 lockers are open, 10 deposits are open, each deposit around 1 lakh, and aggregately all these 10 records collectively deposit around 1 crore rupees today. Okay, so I don't insert all these 10 records into the data warehouse. Instead of that, I'll aggregate it, saying that 10 records and so 10 deposits 1 crore rupees on 2023 July, so 2022 June 23. This is how I aggregate and I store it. I don't copy as it is, because I don't load all the transactional data, a base level data I don't store. I will aggregate it. Okay, I will aggregate it and store it. Otherwise, there is, what is the use if I do the same thing? So what is the advantage of aggregated data?
Yeah.
Whenever you are generating the report, you look for aggregate data, right? So for a day, for a month, for a year, for every 10 years, you'll kind of get the aggregated data. You don't go for the individual data, right? Whenever you're generating the reports, isn't it? So that is the reason I store aggregated data. Apart from aggregated data, what I do, I might perform some data quality checks. That means whether the suppose a name is there, name is wrongly placed, or some invalid places are there in the name, which is kind of a junk record. So wherever the name is has some junk, I'd filter that, right? And whenever I'm aggregating the data, so I want to aggregate the data. While aggregating, I'll make sure that I don't take all the nulls. Okay, and also suppose I'm my decision making process, I want to load the data only if the deposit is less greater than 100 rupees. Just I'm saying. So these are all the quality checks I'll perform. I will aggregate it, I will refine it and store the data in the warehouse. So basically that is the reason aggregated data we are storing, not a basic level transaction, minute level data I'm not going to store. Does it answer the question?
Sure, makes sense. Thanks. Yep, yep. Thank you so much.
So there is a data warehouse. Now, as I mentioned, OLTP is basically used to run your business. Okay, day to day, whatever the transactions you are performing, that you will be using to run your business. And the data warehouse helps to optimize the business, right? Olap. Okay, it's used to run your business. That means day-to-day transactions you'll be performing. Olap is to optimize the business. How do you optimize? Because you're generating the reports, you're analyzing the data, then you will take a decisions based on the data for the business growth, right? So run the business, optimize the business. Excuse me. Sorry. Yeah. So here a producer might want to know different things. Suppose the producer, in the sense the analyst, might want to know different things: how the customers are behaving, which products are being sold, right? What are the promotion channels are being used? If I'm giving some discount for any credit card, what type of credit card people are buying a lot, right? So these are all kind of different analysis that you'll perform. Second. Yeah, so based on different scenarios, the end user will analyze the data and take a optimal decisions, necessary decisions for the future, right? So there is a difference between OLTP and OLAP, right? So if you deep dive more and summarize the actual differences between these two in detail, let's talk about based on some properties. Let's see what all the differences we have. Now this is the front end. Okay, this is the front end where you are performing the transactions. So suppose the bank can be supermarket, hospital. So once you keep on performing the transaction, the data will be stored where? OLTP, the transactional database, the data gets stored. So once the data gets stored over here, so at the regular intervals, you will store the data into the OLAP, online article processing. The storing from here to here can be at regular interval. It can be hourly or monthly or weekly or daily. It can be based on the requirement. So once it is generated and loaded here, finally the reporting users will generate the reports out of it and perform the analysis of the data, right? So that's how this OLTP and OLAP works. So if we take an example between the OLTP and OLAP, if the basic is an example, it's used to manage very large number of online transactions. So this is for basically used for large number of online transaction processing. As I mentioned, if you take in a bank example, hospital example, or supermarket example, you'll have tons of transactions day-to-day basis. Or over the period of time, you'll have lakhs of transactions. So basically, all those transactions will be managed in the OLTP. So OLAP is simply used for data analysis. There won't be any transaction happen. Just to you read the data and generate the reports, right? So before I jumping into next topic, is there anyone who is finding hard with English, or you want me to repeat in Telugu? Anyone has any issues? Kind of a freshers from rural Telugu medium background like me. You want me to repeat anything? Feel free to tell me, or you can even put it in the chat window. Okay, only you can direct my message only to me. That you can do. Okay, so chat window lo message pettochu naku meeru. Okay, if you want to repeat me anything. So based on that, I will explain the topic in English followed by Telugu. Okay, is there is there any case where it kind of bit complex to understand? Feel free to let me know. And also, if you feel that I'm going very fast, push me back. Okay, I'll slow down. But this is a regular speed pace I'm using. Right? If nobody has any issues, I'll follow the same pace and same type. Samsung and okay. So anyway, at the end of the session, after stop recording, I'll go over each and every one of you. Nothing to do. All right. So basic key is used to manage very large number of transactions, is basically used for only for the data analysis, right? Now database type. So obviously this will be used the traditional database management system, Oracle, SQL Server, MySQL, can be anything. And here it uses the data warehouse. Okay, I'll come to this point at the last. I'll re-explain again. Data modification. Looks like there is a this one. I'm unable to change this actually. Yeah. So OLAP is only for reading the data. Okay, only you read it. But OLTP performs all kind of transactions because it happens inserts, updates, deletes, all kind of transactions happens. And here only data reading happens. Processing is little slow. Here the processing is little slow because multiple transactions happens and also the data is normalized. The transaction will be bit slower. But here OLAP, the data, whenever you retrieve the data from the OLAP, it's not exactly milliseconds, it can be seconds also. And whenever you read the data from OLAP, the processing will be very quick because you store the data aggregated. And also if you take the next point, the data will be normalized in the OLTP. The data will be denormalized in the OLAP because the data can be duplicated. That's fine. But I want to, because my focus on the OLAP is not to save the space. It's more about the speed, how fast I can retrieve the data, right? How fast I can retrieve the data is my goal in OLAP. In OLTP, how better I can perform the transaction, how better I can manage the consistency of the data. That is the reason OLTP, the data is normalized. OLAP, the data is denormalized. So that is the reason if the denormalized database, the data will be very quick to retrieve. And OLTP, of course, the data will be bit slow because say suppose I'll take a simple example and suppose you have a product and product category data. Product category I'm maintaining in another table, products table in I'm maintaining all the products table. So whenever you retrieve the data, generally you join these two tables. But when I come to OLAP, so instead of maintaining these two tables, I will combine these two tables into a single table and store the data into a Olap. So what happens? I don't need to join any table. I'll just quickly get the data, whatever is required for me from the Olap. So that is the reason the data will be very quick. Now database type, it uses the data warehouse, it uses the traditional database management system, uses the data warehouse. What is the data warehouse? So earlier, so whatever the data you're storing in the data warehouse, for managing the data warehouse, we use to have same database, Oracle database, SQL Server database, whatever the database you're using for the transaction, the same database we use to use for the data warehouse also. But now, as more and more technologies emerged, we got a separate designated databases for the data warehouse, which has some of the powerful features to support the data warehousing capabilities, like dedicated SQL pool in the Synapse Analytics, okay, and Snowflake. Okay, Snowflake is also data warehousing database, and dedicated SQL pool is also one of the database for data warehouse. So these are all specially designed data warehouse databases are there for data warehouse. That is the reason I use the called, it uses the data warehouse database, right? So this is how we can differentiate between the OLTP, OLAP. So if somebody asks you what is the difference between database and data warehouse, you should be able to say all these differences. It's important even with respect to interview as well. Now, does anybody has any question, any confusion regarding the data warehouse?
Hey, PC.
Yeah.
Yeah, I have one. So I'll give you an example. So suppose there is a bank and a transaction happened, and I took 100 rupees out of my bank.
Right.
Now all the account should be in sync, like everywhere in my mobile phone and online account, in the ATM machine, all of them is should be showing that 100 rupees is gone from my account.
Right.
So in this process, are we using OLTP, is a transaction process, to check my balance, or we are using OLAP?
No, OLAP is nothing to do with the users. It's only OLTP.
Okay.
OLTP is the one which does
So
all
OLTP,
this.
you said, is the process is slow. We're mentioning that OLTP, the process is slow.
Yeah.
So, and I want this to happen immediately. So,
No, it
I
happens
didn't get that
immediately.
logic.
And I'm just
So,
saying, so in terms of the data organized, okay, how the way it's organized, more of a data is kind of a what do you call so data is normalized data, right? So normalized data, it takes considerable amount of time when you compare to OLAP. When I say slow, it doesn't mean that it's too slow. Okay, so it's the way it's
okay.
designed, the database is normalized, multiple tables and all. So that is the reason the processing will be a bit slower. It doesn't mean that it takes some time to display. Okay.
Okay, makes sense.
Yeah.
That's all. Thank you.
Anybody else? ఇంకెవరికైనా doubts ఉన్నాయా? Let me jump into Telugu now. Anybody has any issues, any doubts between these two? Srinath, Swapnil? All right, I'll speak to you at the end of the class. All right, so this is about this one. Now, we need to see how do you load the data from OLTP to OLAP. That is very, very important, right? So you're talking about OLTP, we're talking about OLAP. You say that you load the data from OLTP to OLAP, but how do you load the data into this in traditional data warehousing capabilities? Okay, that's where ETL comes into picture. Okay, that's where ETL comes into picture. So this is the OLAP, all the transactions, offsets, updates, delete, insert. You extract this data, you transform the data so that it will have aggregated data, clean data. Finally, you load the data into the OLAP, online analytical, is a data warehouse. So basically you extract the data, transform the data, and load the data. Okay, this is a ETL tool. This is where ETL tool comes into picture. Right? So ETL tool is nothing, what exactly it does? It loads the data from OLTP, it extracts the data from OLTP, transform it, and load the data OLAP. And you might have, so why this is cube is there? Okay, let me explain this as well. So whenever you're analyzing the data in the OLAP, that is data warehouse, that is decision supporting system, you analyze the data based on different dimensions. Okay, based on different subject. So the subject or dimension can be a product, can be dimension, which products got sold more. Okay, which type of disease is getting more patients, right? And what type of accounts are getting created more, right? Which city has more transactions, more revenue? The city is a dimension, the product is a dimension. 2022 date, what was the transactions? 2022, the date is a dimension. So I should analyze the data from different dimensions. So that is the reason called, it's also called multi-dimensional data, multi-dimensional model. Okay, the OLAP is also called data warehouse, OLAP, multi-dimensional model database, decision supporting system, because with respect to different dimensions, I am going to analyze data. But here the data will be, of course, only two-dimensional data will be there. But here it's called multi-dimensional model because the data is being analyzed with respect to multiple dimensions, right? So ETL gets the data and loads the data into OLAP. Now, if you see some more pointers to the ETL, what exactly ETL does. So ETL provides the foundation for the data analytics and machine learning work streams, because that is where we extract the data, load the data, so that data analytics and machine learning work streams can be done. So what exactly happens? We apply the business rules, we clean the data and generate the reports. It can be monthly reporting, it can be weekly reporting and all. So basically we apply some business rules, we cleanse the data, we aggregate the data, we finally load the data into data warehousing with the help of ETL. So it extracts the data from legacy system, it cleans the data, and finally it loads the data into target systems. Okay, that's where ETL comes into picture. All the traditional legacy systems which used to have were following the ETL technique: extract, transform, load. But all the modern data technologies, as the data keeps on increasing and we are using the latest cloud technologies, we are no longer using ETL in most of the cases. Now we are using concept of ELT: extract, load, and transfer. First, you load the data into the sum of the database. It can be target database or intermediate database, and there you perform the transformations. That's where ELT comes into picture. And here is the ELT actually. So extract, load, transfer. First you load to some database, and within the database only you transform the data. You apply all the business logic and all. Then finally you give the data to the reporting purpose, right? So that's how ELT works: extract, load, and transform. Finally, the analysis will be taken based on the data, right? Now, ELT is a different method of looking at the tool approach to the data movement. Instead of transforming the data before it is written, ELT allows the target system to do the transformation, right? Is Snowflake ELT? Let me talk about it. So the data first to copy to the target and then transformed into the place. Okay, the data first will be data the target and then you do the transformation. So Snowflake is ELT. No, Snowflake is not a ETL tool or ELT tool. Basically, it's a cloud data warehouse where we can have different approaches to load the data into the Snowflake. Either I can do ETL or I can do ELT. And all the integration tools like existing ETL tools, we have Informatica, Data Stage, SSIS, right? Ab initio, all these, and SAP BW, these are all ETL tools. Okay, so the same tools can be used for the ELT operation also, because you load the data first, then you transform the operation. Okay, so yeah, so it's ETL tools but traditional environment. But now everything we are storing, we are transforming the data after loading the data. So it's modern data application. We can say like we have various tools like data factory, data breaks, all these things I'll use to transform the data. So basically, first I load the data using a data factory. If I take an example from the Azure perspective, then I will use either data factory or SQL or data breaks to transform the data into the database. Right? So this is the difference between ETL and ELT. Now let us talk about, in a summarize, the difference between these two. Right? So ETL, what happens? Data is transformed to the ETL server and moved back to DB. So what happens? And the transformations are happened in the ETL server. So what happens? Whenever you perform the transformation will be done in the ETL server. Okay, the ETL server, suppose SSIS you are doing. So wherever the SSIS is configured, in that particular server, SSIS server, the transformations happens. But ELT, what happens? First you store the data. Suppose my target database is some Oracle or SQL server. I load the data into the database. Then I'll perform series of transformations on top of the data. Okay. So in the database, the transformations happen in the ELT. In the ETL, the transformations happen in the ETL server. Code usage, the code usage will be when the huge amount of the data is there, then definitely I'll go for the ELT. And as all the modern data applications have a huge amount of the data, that is the reason people go for the ELT. Code usage, so ETL user for just get the data and you do transformation, and whenever the small amount of the data, you'll go for the ETL. Time maintenance, of course, ETL takes more time because you are kind of extracting the data and you need to select the data. You need to perform the transactions or transformations within the ETL server. That takes more maintenance. And whereas ELT, each and every time you don't need to go and get the data from the source. So you store the data here, then data is readily available. You just perform the transformations. Right? And calculations, ETL, so existing columns can be added and override. But here ELT, the new tables can be added, new transformations, new fields can be added. Now the calculation, let me not discuss because it's not a generic one now. It can happen anything nowadays. Right? Now there is a basic difference between the ETL and ELT. Right? So in all the modern data applications, definitely we are using the ELT technology. ELT approach. Available ETL tools, we have several data tools as I mentioned. So these are the tools I listed down. Yeah, that's about the data warehouse and the tools, various tools, the Oltp, Olap, ETL, ELT, transactional database, and multi-dimensional model, whatnot. We have discussed several concepts with the different terminologies, right? So that should be good for today. And next session, we'll talk about, we deep dive into data warehouse, what exactly different models of the data warehouse, what exactly data warehouse has, okay? What are the various models we have when it comes to data warehouse, okay? So these are all we'll discuss in the next session with the examples. And how do you load the data from the database to data warehouse? These are all we'll discuss in the next session. That should be good. And I'm going to turn off the recording and open for a Q&A, even if it's in Telugu, because some people are skeptical to reach out to me for clarification, right? That should be good. Any doubts so far?
Hello, PC, Mahesh here.
Yeah, Mahesh, please tell me.
Yeah, I have a doubt, like we have a ETL process, we have to extract the data and transform, like whatever the filtering. Suppose there is source system, we have 100 records. Those 100 records we transform into depends on the requirements, we filter into 70 records. Is to target we can load.
Right.
Correct, right. It will save the those 30 records will save the data. But come to ELT process, we have loaded already 100 records. Right. But how can you remove those 30 records again?
You don't remove, that will be there. All the source data will be you maintain in the ELT.
But unwantedly wasting the space, right?
No, it's not about wasting the space in the modern data world. It's all about the availability of the data. Okay, it's all about the availability data, because today we have, but tomorrow you might need those 30 records. For those 30 records, I don't need to go to source and get the data, but it's readily available in my zone, so I can pick it up immediately.
Yeah, got it, but it's not like that. Suppose some orders are there. Those orders already closed long back. Those orders it's not required for future also.
Okay, then I don't while extracting itself I filter it out. I don't get closed records.
Okay, got it.
Okay.
Yeah.
Okay. So any doubts?
So PC, I have one more question in this situation. Then how in ELT basically we are extracting, loading, and doing the transformation. So post the transformation, there should be some result. Where we are storing that result? Because we should be having storing it. So it's ELTL. So it's again a load.
Right.
At the end.
Right. So the data engineering is all about extension of these things. So these are the traditional regular things which I explained, but in the actual world, what happens actually? Let me share that quickly before jumping into the one. Yeah. So what do you do in the general? I wanted to take this in the next session, but let me do it right away. So what happens in the modern data engineering, modern data world? One second. What happened? And okay. So you have your source systems, source 1, source 2, source 3. Okay, temporarily I'll store the data. So most of the cases will use the data lake to store the data in the file system, irrespective of the database, the source type, database or flat file or web data. Finally, you load the data into file system only. You'll convert as a file. I load into data lake, which is in my ecosystem now, which is available, readily available for me now. Now from here, I will transform the data and store it in other place. It can be again a file system, it can be a data warehouse, it can be database, can be anything. From here, the actual analysis, actual data science consumption will take place from here. Got it? But the data is readily available. Now I'll pick it up instead of connecting to the sources. I'll pick it up from here. I'll transform the data and do. So for doing all these things, you have separate zones. You maintain some kind of a zones, which we will talk about it later the stage. What exactly happens actually in the real time. Got it?
Sure, that answers. Yep, thanks.
Okay. All right. So let me stop recording.